Welcome ladies and gentlemen to today's practical, which is energy transformations in common household appliances. As you can see here in front, I have a number of different things that you would most likely find around your house. Have a toaster oven, a kettle, a lamp, a solar car, which you might not find around your house too often, and a transistor radio. And for each of those, what we're looking for is the type of energy that goes into power these particular appliances, and then the energy that it gets transformed or changed into to end up with its final output energy. As normal, there is a practical write-up that is coming up, and for the practical write-up, what you'll need to do is you'll need to draw flow diagrams which show the different energy types. So if you'd like to pause the video, get that down, and then you can recommence the video again. Okay, let's start with our first one, which is this large toaster oven here. Okay, let's turn the toaster oven on there. Okay, so as you can see here, we have electrical energy that's going in to power the toaster oven. And in terms of the output energies, there's a number of ones. Remembering, obviously, the main one that we want out of the toaster oven is basically heat, but we have a little bit of light there that shows us that the power is on. If you listen closely to it, there's a bit of sound energy that's coming through there, and right at the bottom there's a bar that will basically get nice and orange, and that works pretty much like a toaster does as well, and that orange gives off the necessary heat. So that's the toaster oven. Let's turn that one off. Obviously what we have here is the standard sort of kettle. Okay. And again, if we switch this one on, we have electrical energy that's coming in, and obviously the main use that we have for a kettle is to basically be able to heat water. Straight away you can hear that it's starting to make a sound. So there's a little bit of sound energy there, and in addition to that, obviously we have heat being produced as the main type of energy. Let's switch that off because it's relatively noisy. Okay, our next one is this lamp. It's a Millennium Falcon lamp from Star Wars. Pretty hard to see there, but obviously if we turn it up to a color there, and you can see the reflection, what we have is electrical energy coming into the appliance, and that's been changed to light energy there. As with all electrical appliances, electricity will cause a little bit of heat to occur as the electricity runs through the wire, so there will be a little bit of heat, but mainly the LCD light there from the Millennium Falcon. So we'll just leave that on because Star Wars is pretty cool. We have a solar car here, okay, and there's the solar cell on top, but of course if we were to place a solar light onto that, that will then create some electrical energy within the appliance, which will then create movement. So we have an intermediary step there where the solar energy is actually converted into electrical energy, which then gets converted into mechanical energy, or the energy of moving parts. So the end result there is also a little bit of kinetic energy. Now, this is always one appliance that makes my students sort of take note because they really don't see much anymore. This is a standard transistor radio. It's powered by batteries at the back, so it's powered by chemical energy. Obviously today with phones and iPods and the like, they're not very common anymore, but obviously what this one does is it's designed to give a sound.
How much head should there be, correct? What in a standard bar?
You can also see there that there is a little bit of light that's being given off there, and also a little bit of heat energy as well. So we go from chemical energy to electrical energy into sound, light, and a little bit of heat with the moving parts. Now, if you really want to take this practical further, you could actually do more common appliances around your house, televisions, laptops, any sort of a common household appliance would work reasonably well here, because again, what we're looking for is what is the energy that is powering the object, and then what does it get changed or transformed into. As normal, if you have any problems, please see your science teacher, and have yourself a lovely day.